What is the inverse cosine of the negative root of 3 over 2? What is that angle? Negative pi over 6. Now, you need to check the range of the inverse cosine function. What is the range of the inverse cosine function? 0 to what? Pi, right? For the inverse cosine function, the range is 0 to pi. So that means this inverse cosine value must be between the 0 and the pi, right? Now, what is the angle? 5 pi over 6, right? 5 pi over 6. Actually, when you try to evaluate the 5 pi cosine of the 5 pi over 6, you first find the reference angle, that is pi over 6, right? And 5 pi over 6 is in the quotient 2, so the cosine is negative. You have the cosine, negative cosine of the pi over 6, and then you get the negative root of 3 over 2. Okay? So now, we get the first specific solution, theta 1 equal to 5 pi over 6. Now let me sketch this angle in this unit circle. So 5 pi over 6. So it's here. So now, how can we find another specific solution for this equation between the 0 and 2 pi? Actually, if you draw the vertical line, okay, a perpendicular through this point, then you have another intersection at here, right? Then you can draw a ray through this point. You know this angle same as this angle, right? So that means you have another angle for which cosine is also equal to negative root of 3 over 2, right? Actually here this negative root of 3 over 2 and then negative 1/2. Right. Now, what is this angle? Seven pi over 6, right? Actually, it's the pi plus the pi over 6, right? Use the pi plus the pi over 6, then you get this second angle. So now let's come back to the whiteboard. So second specific solution is the pi plus pi over 6 plus the pi. So you have the 7 pi over 6. So by now we find the two specific solutions. Okay. Then we can form the general solution set. S is equal to set of x, such that x either equal to 5 pi over 6 plus the multiple of 2 pi, or this x is equal to 7 pi plus 6, 7 pi over 6 plus the multiple of 2 pi. And from these several examples, you can see it's very useful to sketch the angle, sketch the specific solutions in the unit circle, right? And then it helps you to figure out another specific solutions. So actually, when we try to solve the trigonometric equation of the form cosine x equal to a, we know this equation is equivalent to such a system of equations, same as the y equal to cosine x and then y equal to a, right? When you subtract these two equations, you just got the cosine x equal to a. So this one and the system of equations have the same solution set. They are equivalent to each other. So now let's draw the graph of the cosine okay. So if the a its absolute value is greater than 1, say the absolute value of a is greater than 1, then you have y equal to a either here or here, right? Then in this case, when the absolute value of a is greater than 1, cosine of x equal to a has no solution. So cosine x equal to a has no solution. Actually, the value a is out of the range of this cosine, right? Cosine x, its range is between the -1 and 1. But if the absolute value of a is less than or equal to 1, then this equation has solution, right? And we just went over the several cases, okay, for the value of a. Now let's look at the page 558 and let's look at the summary for solving the trigonometric equation cosine x equal to a. So if the a is greater than -1 and less than 1 and a is not equal to 0, then the solution set to this cosine x equal to a is the set of x such that the x is equal to s plus the 2k pi, or the x equal to 2 pi minus s plus 2k pi. So we just cover this case in the problem 8, right? So this root of 2 over 2 is greater than -1 but less than 1. First, we find one specific solution, so this is the s, right? And then we find another specific solution by 2 pi minus this s. And then use these two specific solutions to form the general solution by adding the multiple of 2 pi to them. Okay, so this s is just the inverse cosine of a. And another special case, cosine x equal to 1 is just the set of x such that the x is equal to 2k pi. So we solve this equation when the a is equal to 1. Another special case, cosine x is equal to 0. So this is just the half pi plus the multiple of pi, not the multiple of 2 pi, right? And another special case, cosine x is equal to -1. So that is the set of x such that the x is equal to pi plus the 2k pi. And when the absolute value of a is greater than 1, this equation has no solution. So try to read this summary when you begin to solve the equation of this type.